welcome to today's episode of Rawkode Live. I am your host, Rawkode. Today we're going to be taking a look at Suborbital, a platform for running WebAssembly applications. And I am joined today by the creator, Connor Hicks. Hey Connor, how are you?
I'm doing well. How are you?
Yes, very well, thank you. Not too bad, not too bad at all. I know it's early for you, so thank you very much for taking the time out of your day and joining us today.
My pleasure.
So I gave a very brief introduction there to what Suborbital is. It's a platform for running WebAssembly applications. And do you want to just give us a little bit of more flavor on that? And I believe you've got some slides to help
Yeah,
us through that as well.
I sure do. Let's try to get this up and running here. Yeah, so I will start sharing those and then I'll give you a little bit more information.
Yeah, and I was really rude. And like I said in that little intro video there, I always mess up the intro. I forgot to even ask you to introduce yourself. Do you want to give us a little bit about you as well,
You
please?
know what? That's the second slide, so we can just go right into that.
Oh, perfect. There we go.
All right. Yeah, so hi, my name is Connor Hicks. By day, I work for 1Password. I lead a team called Product Discovery, I should say. We do research and development for new products. And for the last year or so, I've been working on Suborbital. And Suborbital's goal is to allow building web services, APIs, using functions that are compiled to WebAssembly. And so, there's been several iterations of the project. Originally, it actually used Docker to facilitate, the actual running of the functions. But about a year ago, I decided that it just wasn't it wasn't working the way that I wanted it to. Everything was overcomplicated. There were components that I didn't like how they were designed, so I decided to pivot, if you will, and switch to WebAssembly. So I'll back up for a second and talk about the actual problem that a developer is facing that I'm actually trying to solve here, regardless of the technology being used. And it's really that building web services has gotten more and more complex over the last couple of years, right? The last 10 years even. Everything is microservices or having to string together these complicated serverless platforms. And I'm really having a focus on simplicity. The tagline for Suborbital is build web services that are powerful but never complicated. That's kind of the line that I've been using. And so I really want to make it easier to get a production web service up and running with a lot less fuss. Actually, there's the tagline. So yeah, I am building for a future based on WebAssembly. I've been coming up with this thing called the SUFA design pattern that stands for Simple Unified Function-Based Applications. And I can go through a bit more of what that's all about a little later, but the basic idea is let's make it easy to deploy, make it so that you only have to deploy one thing, unified, function-based, because I think that's a great paradigm. And then application, meaning having a very specific meaning of it is one program that is serving your entire application. You don't have multiple services that are serving the same thing. You can segment your application logic using the functions rather than using individual services. And one of my goals is to really embrace the edge computing movement that's been going on. Things like Cloudflare Workers and Fastly compute at edge. They're starting to take advantage of WebAssembly on the edge. I do think that there's another couple steps further that we can take to really take advantage of that, and I'll talk about how later. And then one of the founding principles of just me as a developer is that make libraries and frameworks and such hard to use wrong, right? There are lots of things that you can there's a lot of libraries that you can get that you can configure every single little nut and bolt down in the guts of the system. And sometimes you can shoot yourself in the foot with that because the maintainer, allowed you to configure something that you shouldn't have been able to configure, and you can, introduce security vulnerabilities or whatever by misconfiguring something. So it's one of the big goals to make that hard to do. So Suborbital is actually a family of projects. The main one, the one that we're going to talk about most today, is Atmo. It's kind of the batteries included project, if you will. It has all of the WebAssembly runtime. All of the 3 projects you see at the bottom are put together to form Atmo, kind of like the Voltron robot. So there's Hive, which is a job scheduler or a function scheduler, and this is where the WebAssembly, the main parts happen are in the job scheduler. It uses Wasmer under the hood to run WebAssembly modules, but what Hive does is it actually makes it multi-tenant, and it manages the execution and memory and communication of many modules all at once. And so that's kind of the core of Atmo. It can be, all 3 of these building blocks, if you will, they can be used on their own if you wish. But Atmo is kind of the plug and play, all in one. You don't need to do anything yourself to get it up and running. And then Vector is an API framework for Go. It does, just make it a little bit easier to build API servers. It's something that I built for myself, and for just making it quicker to bootstrap a Go web service without all the boilerplate that you normally need. And then Grav is it's my favorite little project of the bunch. It's a distributed, I call it a messaging mesh. So you can think of it like a message bus, kind of like Kafka, but it is completely decentralized. It takes plugins for transport and node discovery. So anybody could write a plugin to, use a particular transport, a particular protocol or whatever to do the messaging. But it is really designed to allow scaling up, large groups of instances to communicate asynchronously with one another. So I just wanted to quickly touch on WebAssembly itself and say, there's been a pretty big movement coming up over the last little while for WebAssembly, not just in the web browser, but also in more of a server-side context. And I've got a couple of examples here. The founder of Docker, this is a quote that anybody working in server-side WebAssembly will probably quote at some point in their tenure, which is that if WASM and WASI existed in 2008, we wouldn't have needed to create Docker. That's a pretty good endorsement, I think, from the CEO of Docker. And then the CNCF showed WebAssembly as one of the 5 technologies to watch in 2021. And there's a whole bunch of open source work being done right now. I'm going to show off a couple of things today, I think, a couple of projects, obviously including the Suborbital projects as well, but things like Crustlet, that's one of my favorite projects. I think it's so cool. They were able to basically emulate what they call the virtual kubelet, which is tricking Kubernetes, not tricking, but plugging into Kubernetes to make it think that you're running regular workloads when really it's running WebAssembly workloads. It was entirely written in Rust. There was a big splash about it a couple of months ago. I think it's pretty cool. So there's lots of projects like that that are coming up and making me really believe that WebAssembly is kind of the next big thing. And so I'll just close out the slides by saying, I'm looking for anybody who's interested in coming and working on this. It's been mostly just me for the last year or so. People are starting to try it out. People are starting to get really interested in it. But I am anybody who's interested in coming to help out. I greatly appreciate it. And I am running a little survey. I want to know what people want to get out of a WebAssembly server-side framework. So bit.ly/WASM survey. It'll take 3 minutes to fill out, and I'd love to get everyone's feedback. So with that, I think we can get right into it.
Awesome. Yeah, definitely. That was really cool. I think, yeah, everyone's going to quote that Solomon thing at some point, I think, over the next few years, because it's a very powerful statement to say that, you know, what has now become almost a ubiquitous way of running language and runtime agnostic applications on bare metal and virtual machines. Containers wouldn't be needed with WASM. And I mean, it's not hyperbole, is it? Like, WASM really does have the potential to change the way that we build applications within the next 5 to 10 years. And WASI, I find,
it absolutely does.
Super exciting as well. I was really disappointed, obviously, with the Mozilla layoffs last year. It looked like I wasn't sure if WASI was going to pull through. And then literally just yesterday, my calendar bleeped with the invite to the next WASI meeting. And I was like really excited to see that come back to life again.
Absolutely.
And the Crustlip project, I think I actually wrote an article on that last year as well. Really, really cool thing as well. I was so happy when I got that running. And now we get to look at more WebAssembly stuff. Like, it's definitely one of my favorite technologies. It's just hovering on that fringe right now of really awesome things. So this is exciting.
Yeah. Yeah, and that's something I want everybody to realize. Like, this technology is still very, very young. There's not, you know, been the same level of adoption on the server side as it has had on the browser so far. But the amount of work that the community is putting into it right now really makes me believe that it is, like you said, in the next 5-10 years going to be a really big deal.
Yeah, definitely. All right, thank you for that introduction. That was great. Why don't we get started then? Let's see, where is... Ta-da! I have the Suborbital homepage. So we're going to be taking a look at Atmo. Atmo is the all-in-one batteries included component of Suborbital. I guess I'm just going to click get started, and we're going to work through.
Yes. So this is I just kind of relaunched the documentation for Atmo last weekend. So, you know, we're probably one of the first people to be going through it in full. It used to all live in the GitHub repo, and now it's got its own home. So yeah, we can hopefully take advantage of it today.
Yeah, definitely. Yeah, I don't think these were here the last time I looked. So the first thing I need to do...
So if you could actually pause on the welcome screen, I do want to point out something at the bottom of that page. So this is where we come back to the simplicity part of it. The 3 bullet points you see there is really, it sums up the goal for using Atmo, is that you should be able to get up and running with an Atmo application that is, I'm going to say the word production ready a couple of times throughout this stream, but let's realize that Atmo is still in alpha. So when I say production ready, it will be production ready when Atmo is production ready. So you write these self-contained composable functions, and what that means is all the functions you're going to write are going to be completely unaware of one another. They are meant to be run in isolation, and they interact with the outside world using the suborbital APIs. And then we're going to look at something called the directive, and that's how you build applications with Atmo, and it's a declarative file. And I'm really excited about this part of it, and I'm excited to show it off because I think it's a really cool way of building web applications. And then at the end, once we've built our functions and our directive, we're going to end up with something that I call a runnable bundle. And it is a single file that you can then use to deploy your application. And this really goes back to the simple unified function-based apps. It really, like, those 3 things is kind of the embodiment of that. And it shows, you know, how we can simplify building web services by taking advantage of the properties that WebAssembly gives us.
Okay. So is it, I like the thing in your slides where you said, you know, kind of hard to mess this up, at least from a security perspective. Like, is that because it's what we're going to work with is compiled down to WebAssembly and we're taking advantage of that sandbox environment, or is Atmo and the other components bringing an additional layer of security over the top?
I think it's both actually, because the code that's actually handling these API requests, like you said, it is sandboxed. It does take advantage of the strong security properties that WebAssembly gives us. But in addition, Atmo it uses Vector, that API framework, as its way of deploying the actual web server, and that has a bunch of security best practices built into it. So that is really the goal of making it hard to screw up.
Okay. I'd like to understand. I mean, maybe this will make more sense when we start writing a little bit of code, but I'll throw this out. And if you think, let's just wait and see, just feel free to say that. But, so if a request comes in, the first thing it hits is vector. It works out what function has to be called, and then it speaks to Atmo, and then it runs the WebAssembly using Wasmer, and then you said they're composable. So how does the composition between these functions work? Is something capturing standard in and standard out? I know this has always been a bit of a challenge for WebAssembly runtimes. Do you maybe want to give me a little insight into that?
Yeah, absolutely. So yeah, like I said, Atmo is, you can think of it as gluing those three building projects together. So Vector receives the request. It then schedules all of the functions that are needed to handle that request in the Hive job scheduler. And then Grav comes in, we'll talk about a little bit later, is something called capability groups, which are still experimental, and we won't be able to try them today, unfortunately. But the idea is that individual functions will be able to be executed on different hosts. And the idea behind capability groups is that you can have privileged instances, some of them that have access to sensitive resources, like say your access to your payment provider or access to a particular database. Yeah. And you can have individual functions running on those privileged instances, so that only a sliver of the execution for your request is happening on those privileged instances. But because the whole thing is sitting on this message bus, that is completely transparent to the developer. So you don't need to do any logic related to that transfer of execution, but it is happening under the covers, because the WebAssembly job scheduler and the message bus are all just kind of handling that on your behalf.
Okay. I have loads of questions, but I think let's get started first. Let's see how it works in practice, sure. And then maybe that'll answer a few of those questions, rather than me just bombarding you with loads of trivial newbie stuff. So, let's see. We go to get started. It says here that we need the subo CLI. So
yeah,
let's pop that open.
Yeah, for sure.
And this is all written in Go, right? All the components are.
Yeah, that's right. There's some Rust stuff and some Swift stuff that we'll look at later, but for the most part, it's all written in Go.
And so, sorry, Nico.
Yeah, so this is using a really cool, I don't know if many people are aware of this, but it's a service called Go Binaries. It will allow you to automatically build and install any Go tool to your computer, even if you don't have a Go runtime or Go toolchain installed. So that's how I'm distributing it.
Nice. No, I hadn't seen that before, so that's good to know.
Yeah. So you should be able to just run subo -- help just to make sure we've got it installed properly. There we go. So yeah, so subo is the first kind of component. This is kind of the build toolchain for all of the suborbital products. And the goal with subo is that you shouldn't need anything other than subo and Docker. If you want to install the individual language, tools, if you want to install Rust and configure, the WebAssembly targets, you can, and subo will let you use them. But by default, it will use Docker to build all of your functions. So you can actually rely on it to provide the tool chains if you wish.
All right. We got into trouble, I'm afraid, from the audience. Piping to a shell is not a good idea. Yes, I agree. However, live demos, I think it's okay.
Yeah, and it's going to be up on package managers at some point. That's something that I haven't done in a long time. I need to remind myself of how all those different package managers distribute and whatnot, and get some automation going to distribute that properly. But for now, I think it's an okay solution.
Yeah, definitely. I'm okay with it. I pipe to shells all the time. I know I shouldn't, but still. I'm sure there'll be brew packages soon, next derivations shortly after. And that's why, the community can see how cool this tool is and actually go and help contribute them too. So thank you, Kelly Jacko 6. Yeah. You've just volunteered to do that. Right. Okay, so we've got the CLI. Now we need to create a project. So we just do subo create project, import an API. All right, I like it. I'll keep the name the same. So that says it's downloaded a template. Do you want to kind of add it? What's happening there? What's a template? What's a project in this context?
Absolutely. So there are several different languages that you can use to build your functions. Currently, we have official support for Rust and Swift, and more to come. And so for building those different functions and for just structuring the project as a whole, there are a number of templates for those empty, projects. It's never something that you as the developer would need to care about. They're all just managed automatically, and they're all available in GitHub as well if you do want to take a look at them. But really all it's doing is copying it's downloading a zip of a Git repo in the background and then using the contents of that to bootstrap these empty things on your machine.
Okay, so we get a project directory, a hello world directory, and some source. Let's just pop this open in code, I guess.
Yeah.
Now, because this is WebAssembly, or at least it's compiling down to WebAssembly, can I use any language that supports WebAssembly for my components?
So theoretically, yes. However, the Suborbital API, the library, is required. So you mentioned earlier, like sometimes we can do input and output using standard in and standard out. That's not what's happening here. There is a full library. You can see at the top there the Suborbital Rust crate that is being imported here, and that provides a number of host and guest connections, and so all of the functionality is going through that library. So anytime you want to interact with the outside world, that is happening through these libraries. So any language that has those APIs implemented, and I'll be fair, like they're very small APIs. It's really just some memory management and some input-output stuff. Any WebAssembly compatible language that has a library for it will work. It's just that Rust and Swift are the two that have that library so far.
Well, I'm not going to argue. I'm a huge fan and advocate of Rust right now. I'm pretty much doing everything in the rewrite in Rust bandwagon. So.
Sure. So before we really hop into the function, I'd love to take a look at that directive.yaml that's in the root of the project. So this is what I talked about earlier with the declarative web application design. So this is how we're actually going to string together those functions, and this is where the composability comes in. So what we're doing here is we're actually defining the different endpoints that our application will provide, and then we are composing functions to handle them. So you can see there we have one route defined. It is post to /hello. And we're calling the hello world function that was included with the MD project to handle that. So as we go along, we can add a couple more functions, and I can show you the different ways that those functions can be put together to handle and do different types of logic. But at the end of the day, this is kind of the entry point, if you will, for the application. This is where everything is put together and controlled, and it's nice because it is, from my use of it, it is a really nice abstraction. It really toes the line between needing to write a lot of boilerplate and needing to care about what's happening under the hood. It gives you full control of the execution and what is happening, but it makes it so you don't have to care about how it's happening. The the job scheduler, all of the resources, setting up of the web server, setting up of the message bus, all of that is completely invisible to the developer, and they really get to focus on the business logic.
Nice. I like it.
Yeah.
All right. So this is routing any push request to /hello to run a hello function thing.
Yeah.
Which is
so you can pop back to that.
This, exactly. Which is literally just doing a print, right? Or actually, it's not even doing a print. It's formatting a string and returning it as an option.
That's right. Yeah. So we're going to start super simple. I want us to get this up and running to show that it is working, and then we can start, adding some more stuff to it. So I'll walk through what's here real quick. So it is using this suborbital crate to gain access to the suborbital APIs, the very basic of which is just this runnable trait. So you can see that the hello world struct is adding an implementation for that runnable trait. And then we expose the only required function on that trait, which is the run function. So whenever this function is hit by the job scheduler, it will give you an input, which is just some bytes. And then you provide an output, which is just some more bytes. All of the complicated stuff, all of the extra functionality that you get to take advantage of is done through the API. And so we can pretty much right off the bat just build this and run it and show it that it's working. And then we can continue, working on some. I don't know if you want to follow my instructions or if you want to follow the documentation, but you don't need cargo.
Oh. Sorry, I was just falling into my default and ways there. So
that's okay. You actually can use cargo if you want to, but the point of the subo CLI is that it actually abstracts all of that away from you. So if we dig into the build command, you can do build -- help if you want. We can show what the options are. This will take all of the, I should preface this by saying the functions in a suborbital project are referred to as runnables. So a runnable in the Atmo context is a WebAssembly module. But if you were just using the Hive job scheduler by itself, you can implement runnables however you want. So you can use Go code to build runnables. You can implement a plugin to run Docker containers or whatever you want. So that's why I call them runnables, because it is more generic if you want it to be. But in the context of Atmo, they are always WebAssembly modules. So if we run subo build and then pass dot as the current directory and then -- oh, yeah, sure. That's okay. We can get more into it. So the bundle flag is really what we want, because that's going to create that runnable bundle that I mentioned before. So you can hit that.
Okay, and if I do -- native, it'll use my local Rust tooling. But if I don't, it's going to use Docker based on what I can read from here, right?
Yes, that's exactly right. So we can run the Docker one first, and then we'll show maybe the differences between the toolchains a little bit later. So we have builders, which are Docker images for all of the languages. Well, I say all. There's 2 of them. And the builder images ship with everything that's needed to build your runnables. And so we can abstract away some of the complexity of those individual toolchains and make it a little bit easier for you. The downside of that, decreased complexity is that it's a little bit slower. As you can see, it's having to download a Docker image. Now, it's nice because the slowness only happens really the first time. Once you've got all the images and once you've, done the initial compilation of the runnables, the subsequent builds are pretty fast. However, if you were using your native toolchain, this would already be done 30 seconds ago, but we can continue to talk for a few minutes while this completes for the first time. It shouldn't take more than a minute or 2.
Well, yeah, I mean, I've got a question that maybe is, I don't know, glaring is the wrong word, but you've written all of the Atmo tools in Go, but Go isn't one of the supported runtimes. Is there any reason behind that?
Yeah, it's a very good point. So the current support for Go with WebAssembly is not where it needs to be quite yet. There is an alternative Go toolchain called TinyGo that has pretty good WebAssembly support, and I have been experimenting with that a little bit. But it's honestly just the fact that languages with a simpler runtime and memory layout work better with WebAssembly, and Go's is not the simplest. So Rust, for example, has a very very tiny runtime. It has a very simple memory layout. It's very similar to C and C++, and so it lends itself very well to the WebAssembly ecosystem. But then once Go releases some updates to improve its support, I will definitely be targeting it. It is my language of choice, after all.
So yeah, I have seen the conversations around using Go and like the smallest WebAssembly module compiled. I don't want to make up numbers. I believe it was like maybe 30 kilobytes or something, or maybe it was 300. I remember it being a weird figure. And Tiny Go, I think they got that down substantially. So yeah, I think I do understand that concern. I also have some good news for you from the audience. So 06 Jelly Jack actually took me seriously when I said that was now their responsibility, and I think they've just added Subo to the next user repository. So you now have a next derivation for building Subo. Thank you very much, man. That was
awesome. Wow. There we go. That's awesome. Thank you. So yeah, as you can see, this first build is quite slow.
Yeah, well, I mean, that's a Rust thing, right? I mean, anyone who's been compiling Rust programs for more than half an hour is very familiar with the slow compilation speeds, unfortunately.
Right, yeah. And then I think it'll be quite cool to show, like, we can use the native toolchain after this, and we'll show how much faster it really can be when you have, some of the dependencies already compiled and whatnot. Hopefully this will be done in just a moment, and then we can actually run the whole thing. But I'll talk about what the bundles are first while we're finishing this up. So the bundle it really ends up as a zip file. It's nothing complicated really, but what it will include is it will include your directive, the YAML file, and it will include all of the compiled WebAssembly modules into it. So what will happen is that, oh, there it goes. You can see there the last line says the bundle was created, runnables.wasm.zip. So what will happen is Atmo loads this bundle at runtime. So one thing that I've been having trouble communicating, and that I think might be a little bit confusing, itself is not a framework. Atmo is actually an application that runs your application. So it's more of a platform. The framework is really, the paradigm that it allows you to build applications with, and that is using the directive, using the crate and the runnable API. But Atmo itself is actually just loading your application and running it. It's a little confusing, and I've been having trouble really getting that message across clearly, because I don't even think I can talk about it super coherently at this point. But I hope that makes sense.
Yeah, I think so. I think it does. Okay, so I think our next step is then to run this. Is that right?
Yeah. So you can just do subo dev, and that will spin up a development server.
Directory.
Oh, so you're inside of the no, you're inside of the runnable right now. You got to go up a level. Yeah.
Oh yeah, next to the directive.yaml. Okay, so 06 Kellyjack has thrown in our question at us. They suggest, they may have missed it, but is there a reason that the tooling is written in Go rather than Rust? I think the answer, you kind of just said it, is that Go is your preferred language, right?
Yeah. I am a professionally, I am a Go developer, and Go is the language that I can build things the easiest with. And it's important that, I do think that Go is an extremely good language for building web services, and as soon as it is feasible to do so, I will be providing a Go runtime for Suborbital. But right now it's just not possible. And honestly, I don't think I would have been able to build nearly as much of these projects as I have in the year that I've been working on it, because when it comes to building cloud native type applications, Rust is coming up. Absolutely, it's going to be I think one of the big ones in the next couple of years, but it's not quite at the level of Go just yet in terms of being able to integrate with the other things in the cloud native ecosystem. That's not going to be true forever, but for now, that's kind of where I stand on that.
Nice. Thank you for answering that question. Now, we seem to have a small issue. Is that because I did the subo build inside of the hello world directory? Should I have done a subo build here? Or
let's see like an what's in the directory for a moment. Oh yeah, it doesn't seem like the bundle got put.
I just move it.
Yeah,
here.
You can move that bundle up here. Yeah, there you go. There we go.
So does that mean I have a web service running on port 8080 that I can hit a push request to /hello and it'll work?
Yes. So it seems like running that build command inside didn't pull in the directive. So if we can kill this, we can rebuild it. It didn't look like the directive got pulled in. Otherwise, you would have seen the different routes. So this is something that I need to improve the documentation on. But just the dot and then -- bundle should be good there. It's the CLI and Atmo itself are the newer portions of Suborbital. So some of the ergonomics of it is not quite perfect yet.
Does change in directory mean that my build context has changed and invalidated the cache?
It shouldn't, because the Docker builder gets mounted to the runnable directory itself. The crates index thing is something that I'm working on improving. It does need to update its crates index every time, but there you go. Now that all the prerequisites have been precompiled, we should be good to go. So you can run that dev command again.
Nice. Okay.
There we go. So now we can see that first line. It says mounting the route. That means that we've got all of the stuff that we need, and it has set up the application for us. So now if you just make a post request to /hello, we can just see that running real quick. It's there you go. So you can see here it's just returning you a summary of what the request is. So it's just telling you that that's what happened and giving you the request ID that was generated. And so now we can hop into the Rust function and actually do something cooler with it. Right. So that you're getting that's what is just a summary of what the request is. It's telling you that it's a post request. It's giving you the URI and a request ID. If we want to access the rest of the request and get some more information from it, we use the suborbital crate to do that. So at the top, if you could include another of the subcrates, which is suborbital : rec REQ, in addition to the exactly. So now we can use that to access some information about the request. So if we do, let's say we want to get the body, we can say rec : body _ raw. And then
why am I not getting my autocomplete?
That's a good question.
I can't click autocomplete.
I find personally that the Rust, what do they call it? The Rust analyzer needs to be restarted every once in a while, and that's just my personal.
I actually think I dismissed a message saying, "Hey, we want to update Rust analyzer" when I started it.
That's possible. Yeah.
In fact, I'm not even in the right directory now. Let's not confuse it too much. Let me do that and see. Yeah, there we go. Okay. Not installed. Not that it needs updated. Wonder why that is.
Ah. Yeah. I honestly, language servers in general have been giving me problems lately. Even the Go language server and the Rust language server have both been just causing me issues as of late.
All right. Well, that is now indexing those libraries. It's on 10 of 75. So let's assume that's going to take 30 seconds.
Yeah. For sure. So I'll talk a bit more about what those APIs are. So so the suborbital crate, it gives you access to things outside of the WebAssembly module, and it does so in a very controlled way. So this goes back to the security properties of WebAssembly, right? And we can talk for a second about what those are. WebAssembly modules run inside a nice sandbox. In this case, we're using the WASMer runtime, and it means that only what the host explicitly grants to the module can be accessed. And so that means that Atmo and the Hive job scheduler can control exactly what these modules are allowed to do. And we do that by providing APIs through this crate. So I think it looks like it's working now. If we can grab the body raw, I think that will be a vec, so we'll want to make that a string most likely. Yeah.
Let's see if I can remember how to do that.
There is a util package with Suborbital if you want to use it, because I always get confused by these things.
There's a string. Yeah, it seems okay with that.
Yeah.
Oh no.
Cool. It's okay. You can kill most of the stuff that's inside of the sum, and we can just return that something if you want. There is a if you import the util module from Suborbital, it will give you a convenience function to convert vec to string.
So this is it's the vector of bytes. Why is there no collect? Ah, okay, never mind. What's that helper function called, sir?
Yeah, so if you import the util module, including in addition to those two, then you should be able to do util : toString, I think it is, and then pass in the vec.
Nice. There we go. We have a string.
Yeah. Cool. And then you can delete all the stuff inside line 12 to 14 there, and you can just return something there as your return value. Yeah, something like the variable.
Oh, all right. Okay.
Actually, no, that's a string. So we're gonna want. You know what? I think we went a little bit too far. We want to return evacuate. Yeah, so we can cancel this string. Yeah, I usually do lots of string manipulation with some of these things, so I'm so used to converting it to string right off the bat. But yeah, we can go ahead and just do
body
that.
Raw. Okay. And we're returning that, so we'll leave it as so. Okay, cool.
So yeah, you no longer need that, and you'll want to change input there to an underscore, just because we're not using it anymore. The actual run parameter called input can be a underscore. Yeah. Oh well, I guess.
There we go.
Yeah, there we go. So yeah, what's happening here is when a request is being handled by this WebAssembly module, the Atmo will basically bind that request to this module, and then we use these APIs to access more information about it. So now if you go and build again, we can deploy that server. We can just kind of show that very basic version of it. After this build, we'll set up your native one so that we can do it lightning fast.
I'm assuming I can just pass through any string as the body.
Yeah, that's right. That's the thing about WebAssembly, is that because we are having to pass data amongst guest modules that are written in different languages, and they're all running inside this WebAssembly runtime, we do need to transfer stuff around as bytes. There is something coming very soon into the WebAssembly spec called reference types, where you will be able to pass more complex data structures like structs and whatnot. And did that?
Yeah, it worked.
Okay, cool. So that's great. Yeah, so yeah, reference types will be added to the WebAssembly spec soon, and you'll be able to pass more complex data types. But for now, you're really limited to passing around bytes.
Is there any sort of middleware system where I can inject my own parsers for like, HTTP request headers, deserializing the body into certain structs or anything like that?
Yeah, so that is for now, the way that I've approached this is I'm providing those convenience things for you through these crates. But the goal is to eventually remove any of that custom functionality in favor of the standard language things. We'll need a little bit more functionality in the WebAssembly runtime before we can really do that well. So, for example, we can do that right now. If you, for example, if the body was JSON and and we wanted to access a particular part of it, we could take that body raw and we could, disassemble it into a struct. But Suborbital Crate does provide some functions to do this for you. So we can say let something equal. There's a body underscore field function that we can use to actually take the request JSON, parse it, and pull fields out of it automatically. So we can just key hello or whatever. Yeah, sure. And then and I think that will return. I'm not sure if that returns a vec or a string.
I could just. Oh no.
Yeah. Body field might return bytes as well.
It returns a string.
Oh, okay. So then you want to do, I think it's as bytes to vec or something, like you do as bytes and then dot to vec.
Oh yeah, there we go.
Yeah. So let's quickly set up your native runtime or your native toolchain so we can get those super fast builds. Do you have Rust up installed?
Mm-hmm. I do.
So if you just do rust up toolchain install wasm32-wazi, I think it's toolchain install. Let me make sure I'm getting that right.
Is it toolchain list?
Let me just get the exact one for you.
I'll just keep guessing just now.
Yeah, so rust up target add wasm32-wazi.
Target add wasm32-wazi. Yeah, that looks better.
Yeah. Yes. So these are the kinds of not complicated to install these various tool chains, but I did want to make it extremely easy for somebody to just get up and running with the basic version. And then if they want to add, the easier to use parts of it later, they can. So yeah, you can hit that command. Passing the native flag will just allow it to use your local toolchain. And as we can shortly see, this will be a fair bit faster off the bat than Docker. And then on that second run through, it'll be like milliseconds.
So see let's compile on. So we're now using request body field name. Now, is that going to decode whatever JSON I pass in, or is it expecting me to pass in query parameters? What's the semantics there?
Yeah, so that will pull in from the body, from the request body, just like you have. There are other helper functions for accessing query params. We'll look at HTTP like path params as well, headers, all sorts of things. Those are all provided by the library for you to access.
Oh, nice.
Okay,
so I could actually just do like this was a query param where I passed the name as David or Connor, and it would actually know to parse that to.
Yeah. So we can do that one in a second, and we can actually control that with the directive as well.
Cool. All right. So we got the JSON parsing.
Yeah. So we can look at HTTP paths if you want, or URIs. If we pop open the directive, it looks like code doesn't have the root open, but you can just.
I'm trying to make this as difficult for you as possible. That's what it is,
That's all right. Yeah, it's always a guessing game whether VS Code will properly handle multiple crates in the same project or not. Yeah, so if we just, after that /hello, add a /:name, then that's, setting up basically a path wildcard, and we can then access that in our crate. So if you switch from body field, I believe it is just param, rec : param, I think.
URL param?
Yes, URL param, that's the one. And then, yeah, same thing, we'll pass name, and then we can go back and see that native toolchain in practice. See how fast that was the next time around. All right, and then we should be able to do, we kill all of the, so, right, we're doing it. Exactly.
Sweet, nice, I like it.
Yeah, so those are the kinds of things, as you can see, like a lot of the APIs are designed around building, web APIs. That's kind of the focus for now with Atmo, is really building, like the standard REST API. But that's not the end goal, or at least that's not the entire goal. So the entire goal is to be able to handle, event-based traffic. You should be able to attach Atmo to, a Kafka message queue or NATS, and you should be able to handle any kind of input. That's one of the nice things about the Grav project, is that it accepts plugins for all sorts of different transports. And so connecting to various, messaging or queue systems will be eventually pretty trivial. And so you should be able to handle all sorts of different traffic using Atmo. But, talk to me in 6 months and that'll probably be available.
All right, so I think we've done a good job of showing how we're using Rust to compile it to WASM. We're using the runtime here. Can we now take a look at composition? Can I add a new endpoint and pass data from one to the other?
Sure. So let's head back to the terminal, and we can do subo create runnable and then give it a name.
Call it translator.
Sure. Cool. So yeah, you should have another one in there now, and it'll be empty once again. And so we can, what do you want to build here? We can.
So why don't we just take the hello world, which takes the name and the URL parameter right now. So I pass in David O'Connor, and why don't we have the translator just reverse the string and spit it back out?
Sure, sounds great. So this brings us to the declarative application building, and this is the part that gets me pretty excited. So if we open up that directive file for just a moment, I want to walk through some of the basics. So you can see here in the handler, we name a number of steps. And so what's happening here is that each step in the chain will produce an output. So the hello world one will just spit out the name from the URL. Every time a step completes, the output gets saved to what's called the request state. And this is basically a map or the key value pairs that is, constructed for each request. And if I want to access the state from one of the runnables, the suborbital crate, the library, will allow me to do that. So when this hello world function runs in the first step, its output will get saved to state. And then the second step, which will be our reverse, will be able to access that state and pull the value that was output in the first step, and then use that to do whatever it wants with. So on line 14, right where your cursor is, we can add another fn, exactly like the first one. And we'll say translate, I think you called it. So this will now, in the translator runnable, we're going to access that state and figure out what that hello world function gave us. So you can use, we're going to import that rec module again, because we're going to be accessing the request state. And yep. And so if you do rec : state, I will put it in a variable. So let name equal, rec : state.
I'll give it a second, see if it catches up. All right.
Yeah.
I think it's just a model phrase. Let me pop it open and just a translator.
Yeah, sure. Those pesky language servers.
Yeah, they're not.
I think
they don't handle model repos really well, I don't think so.
Yeah.
Okay, now that looks a bit healthier. Cool. Oh, I've not done a cargo install yet. Do I need to, or a build, or?
So VS Code usually does that for you, but I mean,
well, it does this fetching metadata. All right. So.
But I mean, we can run a subo build, and that will build all the prerequisites and stuff if you want.
Yeah, why not?
So if you're inside of a runnable, I mean, yeah, sure, you can do the whole thing if you want. That'll build all of them. But if you just want to run one, you can do that as well. But yeah, go ahead and do that.
Yeah, it seems a bit happier now. Potentially. There we go. All right, so it just wants a key.
Yeah, so we'll just ask for, so in this case, we're going to ask for hello world, because that was the name of the function. But that's not super ergonomic. So let's go back to the directive, and we can actually make that a little bit nicer.
I'm in limbo. Oh, I've got a beach ball. Okay. Let's open up this whole thing again.
You can just maybe add the directive file if you don't want to add the whole thing.
We just got the most important question of the day. What is my VS Code color scheme? It is
very nice.
This one is called plastic, I believe. Panda syntax. It's not plastic. There we go. Panda syntax. All right, we wanted the directive. Okay, so we want to improve the ergonomics of the passing through state.
Exactly. So by default, the value in state, you want to make that a nicer name. So underneath the hello world on line 13, we can add a new line, and we can say as, and then a colon, and then name. So the as clause is one of the things you can use in the directive to make the state easier to work with. So it basically is like assigning to a variable. We're saying run hello world and save it as name. So now we can pop back to the translator function, and instead of requesting it as hello world, we can just request it as name, and it makes a lot more sense from the perspective of the developer. So then we can do our magic to do the reversal. I'm going to let you handle this part because a Rust developer I am not.
Yeah, I never really planned this through today.
I will do some quick Googling.
Sorry, this is how I code anyway. I don't mind showing people. So Rust reverse a string.
Yeah, it looks like .chars.rev will
there we go.
Do it.
Does that return or does it mutate? Yeah, okay.
Oh, and then you might want to .collect from that.
Okay, so reverse equals. And because we're doing a collect, we need to specify the type. There we go. So now We can use our util function.
That's right.
Oh no, we don't need it because it already is. Oh no, we need bytes. Okay, reverse.
Yeah.
Bytes.
.2vec, I think, as well.
Yeah, that's right. Yep. Thank you. And this doesn't need to be mutable. Let's get rid of that yellow squiggle here. Oh, too much, too much. Appease the compiler. All right.
Yes. Great. Okay, so now let's just revisit the directive to make sure that we are summarizing what's happening. So we're running the hello world function. That's returning the name from the URL parameter. We're saving it into the request state as name, and then the translator function is going to take that name and give us the reversed version. So we can build that and let it run. Great.
Hey, it worked.
There you go.
I mean, of course it worked. Like, never any doubts.
Hey, in my head, that's what I'm thinking. Yes, it worked. So this is the composition, right? You can do all sorts of different things. Now, there's one more little superpower of the directive that I'd love to show off. If we could create one more runnable, I do want to show some of the powers that WebAssembly gives us. So if we create runnable, let's just call it, you know, the thingy. Yeah, sure. Now, it can honestly, we could just leave it as the default. It doesn't, what it actually doesn't matter. If we pop over to the directive for a moment, we can do something pretty cool. So let's say we want to run a bunch of these functions in parallel. Say you want to do a whole bunch of data fetching all at once. Say you want to, you know, connect to a bunch of different resources and pull in a bunch of different data. We can use what's called a function group here. So let's go in here. We can just pass group as the instead of fn, and then we'll have to go down a line and then add a couple of fn's to that group. So yes, I think that should do it. You never know with YAML indentation, but so we can actually put, yeah, we can do that, or we can actually put, you know, the hello world in there as well if we want to. And so what's going to happen here is that the job schedule will actually run all of these functions concurrently, and then all of their results will be put into that request state. So if you wanted to do parallel processing, if you wanted to, you know, save to a database and a cache simultaneously, these are the kinds of things that you can do, with a function group. And it's really nice because you, as the developer, you don't need to do any of the logic that you would normally need to do to run these things concurrently. You know, if you were a Go developer, you would have to be dealing with Go routines, you'd have to be dealing with channels, you'd have to be making sure that they're all blah, 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 succeeding. But with this, we just say, hey, we want to run these functions in parallel, and the job scheduler will figure it out. So, you know, we don't necessarily have to run this because it's not going to look any different from an output perspective. But, you know, I do want to just kind of point out that these are some of the things that we can do with it.
So I think there's two questions in my mind right now. Now, I'll start with the first one, and then I'll go into, well, I guess it doesn't matter. They're still in my mind. So the first question is the bytes that we're passing back as the state of each of these individual functions the only way to transfer state between the functions? And I guess the example I'm thinking there is if I wanted to do any form of image manipulation, would I have to store those bytes in memory and return them, or do I have like shared disk across the invocations at all?
So currently you can't access the disk. That is something that I will be adding once I can get WASI working reliably across both of the Rust and Swift. But what you can access as a shared resource is a cache. So there is a Suborbital API for accessing a cache. If you want to connect to Redis or something like that, you can do so. I do plan on adding more APIs very soon, which will let you access more resources like that. Like one of the things I would like to do is give access to, static files. If you want to serve, a static website, you should be able to include those files into the bundle and allow, your runnables to access those files. So these kinds of things, accessing shared disk, accessing files, connecting to more things outside of the modules. These are all things that I'm designing right now and I'm working on building up. But they each have to be built individually and they all have their own security concerns and whatnot. So I'm trying to be a little extra careful with some of those things to make sure that I'm building them in a way that, won't let you screw it up.
All right. And my second question is, like, we're now in a stage with this, directive file that we have. Our first step, we then have a group which runs 3 in parallel, followed by our final step, which is a translator. If I were to run this like so, sorry, let me try and articulate this question in a way that makes sense. Like, I only see the output from the final step. And if I wanted to debug something in the middle, is there a pragmatic way of handling that at the moment?
Yeah, so there's 2 things that you can do. One of them is that the suborbital package provides some logging functions. So if we want, we can go back to the translator, for example, and we can add a little bit of logging if you like. And then the other thing is you can control which function's output is used as the response, and we can do whichever of those 2 things you want to do first. So if you just import the log module, then if you want, we can say log : info, and then just pass in. You'll have to do an as stir on that, or that works fine. So now we can run that and see that being logged right off the bat here. You can see how much faster the native toolchain is than the Docker one. So then somewhere in the middle, you can see stuff and things popping out there. And so the other thing that you can do is if you want to take the output from a particular function, we can head back to the directive. And you can use the response option. So right at the end of the handler, at the same level as the steps key, like we can go right to the very end. Or it doesn't matter. So if you just say response : and then choose one of the names. So if you wanted to do thingy as the output, you can actually tell it this is the one that I want to take the output from to actually respond to the request with. So this one will probably just be that default, once again, the summary of the request, because we didn't actually change the thingy runnable.
All right, cool.
Yeah, and this helps that, like, if the last step in the chain is a group, right? That there's no logical way to choose between the functions in that group, and actually Subo will error out if you just have a group as the last step. It will tell you that you must give a response field to make sure that it's unambiguous.
Okay, is there docs on this directive file and all the things that we can?
Yeah, absolutely.
Because like one of the things that's popping into my head, and probably may not exist yet, would be like flow constructs within here. Like if I could do for each and then tell it like it was from whatever I got from Hello World, maybe it returns like the vector of base has like something I could split on, and I can say split on a comma, like where I could actually build for loops with. Obviously I can do that in the translator lib.rs, but to build that into the directive I think would be really cool. And of course maybe like conditionals too, so only if this var is defined or whatever, and like really starting to build out complex, I guess workflow is kind of what I'm thinking of here.
Absolutely, that's definitely in the plan. The for each one particularly, I was planning on doing that very soon. I was hoping to get it done for this live stream, but I haven't quite gotten that part finished yet. But absolutely.
Plus, I'm identifying areas of the project where I can hopefully come and help out now. Because I can see loads of use cases for a tool like this. I like building event-driven applications, and this is like the perfect thing where I could just build out all those functions in isolation and then chain them together with the composition. It seems like a really powerful tool. I'm very impressed.
Yeah, thank you very much. Yeah, it's this is one of the things where I was developing, the three building blocks, right? The Hive, Vector, and Grav, and this idea, the idea of the directive, when I kind of thought of this concept, that was when it really clicked for me of what Atmo was going to be. I thought it was just going to be, you just write code and you have to call the functions directly with some Go code or something. And that felt fine, but I wasn't super excited about it. And then when this idea of the directive came up in my head, that's when I started to get really excited. And that's the day that I created, I actually started the Atmo repository and started actually building it, because that was the thing that got me super excited.
Sweet, excellent. So we have another comment on my theme. So Kelly Jack says, that's not what it looks like on mine. Jump in the Discord. I'll chat to you there. We're not going to be able to live debug that here. Okay, so we've covered, sorry for the segue there. We've covered a fair bit of this. I'm excited by this tool. I believe you've got a few more advanced demos that you may want to show us.
Sure, yeah. I will show off, one or two more bits of the runnable API. Let me make sure. Let's get that screen share up and running again. Cool. Just gonna make sure I'm in the right. Is that font big enough, do you think? I can make it a bit.
I mean, it wouldn't hurt to go in a couple more for sure, but it's readable, yeah.
Yeah. Okay. Okay, cool. So we're going to go into, I have my own important API, of course. So of course that opens in the wrong screen. All right, so I've got a runnable here. That this is available in the Suborbital GitHub if anybody wants to take a look at this one.
Could you zoom in on that a little bit as well, please? Yeah,
absolutely. I'll get rid of this bottom and make this smaller so that you can really see it. Okay. So yes, this is available in the Suborbital GitHub. It's called Important API. That's what, it's very very useful. And it's designed to show off more of the APIs that are available. So, we've looked already at like rec, and we've looked at log and util, but there's one more that I want to show off, which is HTTP. So by default, WebAssembly can't access the network. And in fact, even the WASI specification, it still doesn't quite give full access to networks. There's some things coming up. There are some things currently in development. There are some limited things available already. But I wasn't fully happy with it, and I wanted to build my kind of own version of it. So the Suborbital library provides this HTTP module. And what it lets us do is make HTTP requests. So I've got this runnable here, and all it's really doing is it's using, the rec module that we've already looked at. It's checking a URL param just like we did a minute ago. And what it then does is it's going to go hit the GitHub API, and it's just going to get the details of whatever repository we pass in as the field in the URL. And then we're going to do something, pretty standard. We access the field directly in the example that we did, but I'm going to just show that this can be a regular Rust program, right? You can use serde, and you can deserialize JSON, and you can do whatever you want here. So we are going to take the response from that GitHub API request. We are going to create just a summary of the stargazers, so like the star count on that repo, and then that's what we're going to return. So I'm going to build this. Build native bundle. And obviously I've built this once already because that was super fast. And then we're going to, I'll start this up in my other terminal here, sudo dev. And wow, it really, oh, something's already listening on that port, apparently. What do I have running? Apparently, I already have one running. Let's try this again. There we go. I'm going to clear this. So
I hope that last one wasn't important.
No, I'm pretty sure that was just me preparing for this demo. Right, so you can see, we're mounting this this route. It has a different style of wildcard. This lets us pass any kind of path that we want. And so we're going to hit localhost 8080/stars, and we'll do like suborbital atmo, for example. And as soon as we hit that, it is going to execute that gh_stars function, and then it's going to return to us information from that GitHub API. And we can see that it did do some logging, fetching stars for suborbital atmo, and it did all of the JSON parsing with Serde, et cetera, et cetera. And so, this is just one of the other APIs. And then the last one that we can just take a quick look at is the ability to access the cache. So say I wanted to, cache this API response. There is one more here that we can access. Probably should make it the first one. The suborbital cache one. So we can say cache set is not colon. And then we can say we want to set, we'll call it we'll put it repo as the key, because we want it to be specific to the repo that we are requesting for. And then the value can be those repo details. And then we'll set the TTL to 0, so it never dies. And so then, oh, this is going to yell at me, isn't it? Borrow moved value. And we need to do, I think, as owned? No, to owned.
Clone.
Yeah.
Okay.
Oh, yeah, clone, yes. See, I'm getting a lesson right here on some Rust best practices. So then, the nice thing about WebAssembly and Atmo is that you as the developer, you don't need to care about the cache, what it is, what it's connected to, how it's configured. The cache is bound at runtime. And so all of your functions can use this API, and then maybe in local development, it's using an in-memory cache, but then in production, it could use Redis or Memcache or whatever. And you as the developer don't need to care. You just bind to this API, and it will figure itself out at runtime. So yeah, those are just a couple of the extra pieces of functionality that it has. More coming. The thing that I'm working on right now is accessing databases. I think that's kind of the last big piece to really make this usable for the kind of average API application. Access to a cache and access to a database. Those are like kind of the very bare minimum things that you need. So hopefully within a month or two, there will be a suborbital DB here that you can use to do some SQL queries, or maybe it'll be GraphQL. I don't know. We'll see where we end up with that. But yeah.
Awesome. Very, very cool. I like it.
Thanks.
So we've covered quite a lot. I hope that gives the people that are watching an idea of the project, what its use cases are, why you would want to use it. You even give us a little bit of extra what's coming kind of next there as well, which is also fantastic. Is there? I mean, we kind of deviated, right? We paved our own path there instead of even using your brand new documentation. I feel a bit bad there, but I still feel that we showed off the platform. The docs are here for anyone that wants to pop in through. So I'll leave you with this then. How can people contribute? What do you want help with? And is there anything else that we haven't covered that you want to just quickly drop in at the end there?
Yeah, absolutely. So for contributions, literally anything. And I say that with the broadest sense. So it doesn't matter if you are a Go developer. It doesn't matter if you've never used WebAssembly before. It doesn't matter, what operating system you're using. I want anybody to be able to contribute to this. And whether it's documentation, whether it's working on the CLI, whether it's working on the job scheduler, any of the components really. I'd love to have people come and help build these things. In particular, like I've said more than once here, I'm not a Rust developer, and we didn't even get a chance to dig into the Swift portions of things, because there is a support for Swift here as well, Swift developers as well. Anybody with experience in those languages, very much appreciated any help that they could give. And then I want to bring additional language support as well. So C, C++ developers, anyone with who's used assembly script and wants to come in and build that with us. That's really fantastic. And then even if you don't want to contribute code, use Atmo and find where it breaks. That is one of the best things that you can do, and help me get it from the alpha that it is today to something that can be used for real world workloads. Show me where it doesn't work for you, not just from like a crash or a bug, but ergonomically. Where does it feel awkward? Where do you see it as being inferior to building an application the old-fashioned way? Any of those types of things are always immensely helpful. And then taking that survey, so the bit.ly/WASM survey, I want to know, it's really just 5 or 6 questions about languages, capabilities, and things that you would want to see from this type of framework and platform. And I've forgotten what your second question was.
Yeah, was there anything else that we haven't mentioned that you want to quickly add on?
Oh, that's right. The Atmo itself is fantastic, and that's my main focus, but the individual projects are also completely usable on their own. If you just need a job scheduler, Hive is fantastic. If you want to just make building APIs in Go simpler, Vector is really great. If you want a decentralized message bus, Grav is fantastic, and contributing plugins for Grav, for example, would be really great. They are super easy to build, and the documentation is not fantastic, but it's really fun to build on, and I'm really quite happy with how that project is coming out. So any and all of the projects are open for new users and contributors.
All right, awesome. Well, thank you very much for getting up early, joining me today, for your work on Atmo and WebAssembly, and providing tools to make this easier for people to adopt. Really good to see.
Cheers, it's been great.
And I'll let you into a little secret. My secret power is breaking software. So give me a couple of days with this, and I will find you the bugs that you're looking for.
That sounds great.
All right. Well, thank you again. I hope you have a great day. I'm looking forward to seeing where this goes, and I'll speak to you again soon. Thank you, Connor.
Yeah. Cheers. Thanks so much.